brain, as it processes the sounds of our lives, was not a straight line. In college, my interest in words and languages led me first to comparative literature. That was my major until I took a course in biology. Around the same time, I found a book by Eric Lenneberg, Biological Foundations of Language. Sound familiar? In it, Lenneberg wrote about biological and evolutionary principles that make language possible. It married the study of language with the study of biology in a way that was new at the time. That got my attention. I realized this area of study was possible, and I knew it was the one I wanted to pursue. But I did not want to limit myself to language. I was interested in the broader topic of sound itself. Sounds are all around us on the outside, but what goes on inside the brain when we hear a word, or a chord, or a meow, or a screech? How do sounds change us? How do our experiences with sound change how we hear it? I had homed in on the biology of sound processing as a field of study. When I got to graduate school, I realized I could get paid to learn. My monthly stipend was $200 and my rent was $50. I was set. Now I just had to figure out what route my pursuit of the biology of sound processing would take. I soon found myself in a lab studying two-tone suppression in the auditory nerve of the chinchilla, the influence one sound has on another when both sounds occur simultaneously. As I was enthusiastically explaining all of this to La Mama, she looked at me and asked, "Nina, what are you doing?" At that moment, I realized I could not explain why two-tone suppression in the chinchilla should matter to her. Why would I want to research it? "Nina, what are you doing?" It became clear that if I couldn't explain to my mother how I was spending my time, I didn't want to be spending my time that way. I realized the science I do needs to be explicitly grounded in the lived world. I was still immensely interested in sound and the brain, so I moved on to my next lab, where I worked with rabbits and the auditory cortex. There I discovered that with training, learning to assign meaning to a sound, the individual neurons in the auditory brain changed their behavior. When a sound has little meaning, the brain will respond to it one way, but when that same sound has acquired relevance, food is on the way, for example, the brain responds differently. A sound-brain partnership is formed, connected to the living world. The meaning of the signals outside the brain matters to the signals inside the brain. This was news at the time, and, more importantly, it was something I could explain to La Mama. She could see the significance of it. Anyone could. I intended to find out how and why the brain changed its response to a sound that had meaning. Sound connects us to the world. The ability to perceive sound is evolutionarily ancient. All vertebrates have a mechanism of hearing. In contrast, many vertebrates are blind, including some mole, amphibian, and fish species, and a host of cave dwellers. Sound perception evolved for self-preservation, a warning system against predators or other environmental dangers. The stressful feeling the clanging roar of traffic causes may be a 21st century shadow of our distant ancestors, reacting to a noise signaling a coming avalanche or stampede. Helen Keller commented that blindness disconnects us from things. Deafness disconnects us from people. Sound represents things we cannot see and cannot describe. Think of how your mother asks, "What's the matter?" the instant she picks up the phone and hears your not-quite-right-sounding voice. Sound is unseen but is palpable and